So there are two areas of the brain where we have what's called a cortex. And a cortex, there's a definition of a cortex, but basically what it is an outer rind, an area that is layered and contains a very particular type of cell, and it sits only on the outer surface of a brain structure. And the two areas that we have cortices, one is the telencephalon, the cerebral cortex, and the other one is in the cerebellum, the cerebellar cortex. So what's similar between these two areas? Well, they both have these hills and valleys. They're named different things, but they account for the same thing, which is that they increase the surface area, because cortex is only there where there's a surface. So to get more cortex, you have to make more surface area. In the cerebral cortex, that's done by making these hills and valleys that are called sulci and gyri. And what you can see, I've taken a piece of brain and I've cut through it, and what you see here is gray. Do you see this gray that just decorates the outer surface of the brain? It's the rind, that's it. It's not very thick. That's the cerebral cortex, and underneath it is white. Why is this gray? Because there's not very much myelin. Why is this white? Because there's a lot of myelin, because there's a lot of axons. So gray matter is rich in cells, and white matter is rich in axons. This gray matter that forms the outer surface of the cerebrum is the cerebral cortex. When we look at the cerebellum, we see the same deal. It's just smaller. The hills and valleys are much smaller. In fact, they're called folia. But the name of it is not that important. What's important is that you can see that there's this outer gray area served by a inner white matter. Okay? So this is the cerebellar cortex, and this is the cerebral cortex. This type of structure is what's contained everywhere you see this. All over this telencephalon, that's all cortex. So that is the final way that we've expanded the surface area of the cerebral cortex. But let's remember back to how the central nervous system and how, in particular, the brain develops. It develops from a hindbrain swelling, a midbrain swelling, and then a forebrain swelling. And the front of that neural tube is called the lamina terminalis. And the front of that tube is right here. It's right there. Okay? So we have hindbrain, midbrain, and forebrain, and it ends right there. That's where the tube ended. So what the heck is all this? Well, all of this is the brain, is the telencephalon saying, I want more space, and growing back over the rest of the brain. So, in fact, as we go like this, we can see that it's grown on top of the hindbrain. There's a space there. There's no brain here. It's just come back on top of it. And there is a space. Here's the lamina terminalis. It's right in front of the optic chiasm. This is the front. This is the back. Here's the cerebellar cortex. Here's the cerebral cortex. This is arachnoid. And what you can see is that the cerebrum actually sits on top of this structure, and it's actually separate. They're not joined. This structure right here is thalamus. That's the thalamus, and it's not joined. There's a space between the top of the thalamus and this overgrown telencephalon that has grown back on top of it. In that space is this small little gland. It actually attaches right there, and here's half of the gland. It's been cut in half. On this brain, here's the gland. Here's the gland right there. It attaches right there. That gland is the pineal gland. The pineal gland is important in circadian rhythm. It secretes melatonin. For our purposes, this gland is pretty important because these pineal cells can become cancerous. They can start to multiply. And if they multiply, they're going to take up more and more space. And you can see that even though this is not part of the brain, it's an actual gland that's got stuck inside of the cranium, that if this expands, we're going to have brain problems because it's going to put pressure. It puts pressure primarily on the midbrain. And one of the things that it does is that it closes this cerebral aqueduct. So can you see that if this were to increase in size, it would press down and close off the cerebral aqueduct? That's a problem, and it causes a condition called hydrocephalus. So the important point here is just to understand that the cerebral cortex, the telencephalon, has expanded so much that it's covering the underlying diencephalon, it's covering the underlying midbrain, and it's covering most of the hindbrain as well. The telencephalon is a hungry beast, and it wants to expand even more. And the final expansion, or another expansion that occurs, is this temporalization. And so the telencephalon has expanded back here, and then around and forward like a ram's horn. So it's coming around and forward to form this temporal lobe. This temporal lobe is only present in some mammals. It's present in us, it's present in several, it's present in the apes, it's present in several other primates, but not too many other mammals. So this is houses a further expansion of the cerebral cortex over what's present in a general mammal.